Hello everyone, thank you for taking the time to watch this presentation. As the title suggests, I have chosen to explore how psilocybin might be used to reduce anxiety. So let's get into it. So on today's trip, just to provide you an outline quickly, we'll talk a little bit about the history of psilocybin. Also, we'll cover the pharmacokinetics, the pharmacodynamics, behavior, namely anxiety, and then we'll wrap things up. So the earliest recorded use of psilocybin dates back to 1500, and it was used for ritualistic ceremonies. Today, there have been 57 species of psilocybin discovered. Psilocybin is a Schedule I drug, indicating there isn't currently an accepted medical use and has a high potential for abuse. However, we will discuss why this scheduling isn't entirely appropriate. Some common street names include mushies and shrooms. So that covers the history and some background information on shrooms. Let's get into the fun stuff. The pharmacokinetics. So the most common route of administration is oral consumption, and through this, most of the absorption will take place in the small intestine. If you have food in your stomach, that's going to slow the rate of absorption, and first-pass metabolism is going to decrease the bioavailability. Now, to avoid digging too deep into the weeds here, this is the metabolic process of psilocybin. It is important to note that psilocin is the active component and is responsible for the effects on the brain. The peak plasma concentration is 1 to 2 hours post-consumption, and the half-life is between 2 and 3 hours. The metabolic degradation of psilocybin does follow first-order kinetics, so the more you consume, the quicker it will be metabolized. So that's metabolism in a nutshell. How about depot binding? Well, most of the literature suggests that psilocybin and its metabolites are out of the system within 24 hours. So with that being said, it is unlikely that depot binding is a major factor to consider when discussing the prolonged bioavailability of psilocybin. So now we get into the pharmacodynamics. Psilocin is a serotonin receptor partial agonist. Given their molecular similarities, it isn't a surprise that psilocin has an affinity for serotonin receptors. From this point forward, you'll hear me refer to these receptors as 5-HT receptors. It's synonymous with serotonin. So psilocin has the highest affinity for 5-HT2A receptors, and it's this interaction that is linked to the psychedelic high associated with shrooms. Psilocin does have a strong affinity for 5-HT1A receptors as well, however. Where are these receptors found in the brain? Really all over, but the highest density of 5-HT2A receptors are in the prefrontal cortex, while the highest density of 5-HT1A receptors is in the amygdala. Do note that 5-HT2A receptors are stimulatory, and 5-HT1A receptors have an inhibitory effect. These downstream effects will come into play very soon. But here's a wonderful image that kind of brings everything we've talked about together so far. We consume psilocybin mushrooms. First-pass metabolism converts psilocybin into psilocin, which will then bind to 5-HT2A or 5-HT1A receptors and have their downstream effects. Several behaviors are listed below, which allows me to make this seamless transition into behavior. But before we get into psilocybin's effect on anxiety specifically, we have to discuss the open field maze. It's a frequently used test to measure anxiety. And so what scientists do here is they place these mice in this open field maze. If they spend more time near the wall, they're considered more anxious. And if they spend more time near the center of the maze, they're considered less anxious. Now, in the study I've chosen to present, researchers use a modified version of the open field maze, but the principle remains the same. Their findings strongly suggest that psilocybin can be used to reduce anxiety. Here we are focusing on the center exploration portion of the chart to the far right of each graph. Mice that were given doses of psilocybin were much more likely to spend time in the center of the maze, indicating they were less anxious after administration. So what's happening in the brain? In an individual who is suffering from anxiety disorder, they often exhibit overactivity in the amygdala compared to prefrontal cortical activity. On shrooms, however, this trend is reversed. As I mentioned earlier, psilocin binds to 5-HT2A receptors in the brain, and there's an abundance of these receptors in the prefrontal cortex. You may recall these receptors are excitatory in nature, so it isn't too surprising to see increased prefrontal cortical activity. Ultimately, the data suggests that shrooms increase our ability to regulate emotional processing occurring in the amygdala more efficiently via inhibition by the prefrontal cortex. Now, to wrap things up, I wanted to share with you psilocybin's influence on dopamine and the reward system, withdrawal tolerance, and dependency. And truth be told, there isn't any evidence that I could find supporting the notion that psilocybin has any effect on the dopamine reward system, dependency, tolerance, or withdrawal. Certainly, research is ongoing. So, in a bit of an anticlimactic fashion, this concludes my presentation. If you're interested, here's a list of references. Thank you for listening.